fractions. I love my fraction. Oh, hey, how's it going? Mr. Snyder here. What we're going to do today is we're going to be looking at adding and subtracting fractions. This is, again, one of the tricky ones, but as long as we remember all the tools that we've learned in the past couple fraction videos, I think we can put it all together here and figure out how to do adding and subtracting fractions. All right, here we go. First problem that we're going to do today is negative 9 over 10 minus 3 over 10. And while I'm still writing, let's go ahead and just put this second problem up here. 1/2 plus 5 halves. Okay. So how do I do subtraction? How do I do addition with fractions? Number one thing you need to make sure of is you need to make sure that when you're adding and subtracting fractions, that the bottom or the denominators of both fractions, or 3 fractions or 4, depending on how many you're adding together, make sure that all of those fractions have the common denominator. Okay, so for this first problem, you'll notice that I purposely did a problem where the denominators are the same. So negative 9/10, 3/10, both have tenths, so you can actually go ahead and subtract that right away. And then the other one perfectly works as well because, again, the bottom numbers are the same in both the left and the right fraction, okay? They have common denominators, so therefore you can go ahead and do your adding or your subtracting or what have you. Let's do the first one. When you're doing subtraction, for example, you want to make sure that the bottom number just stays the same, okay? If you have questions a little bit more on why that is the way it is, pull me aside in class and I can really explain it to you a little bit more in depth. Now, the top part doesn't just stay a 3 or doesn't stay 9. That's where you actually can do your normal subtraction problem, okay? So let's look at this. It's asking us to take negative 9 and subtract 3 from it, okay? Negative 9 minus 3, well, that's just going to give me negative 12, okay? Negative 12 is not reduced, especially when we divide it by 10, so let's reduce that, okay? Both of these are divisible by 2, so let's see here. Negative 12 divided by 2, that's going to give me negative 6. 10 divided by 2, well, that's just 5. So negative 6 over 5 is my final answer. Yeah, final answer. So exciting. All right, the next one, let's do the addition problem, okay? So 1/2 plus 5 halves. Again, we're going to just leave the denominator the same. We haven't touched it. We just rewrite it. It's pretty straightforward. The top, though, we do have to make the addition problem. So 1 plus 5, that gives me 6. Now this one actually can just be divided and it gives us a solid whole number. So 6 divided by 2, that is 3, okay? Because 2 goes into 6 3 times. Okay, so there is the answer for both of our problems. Now, I wish that the problems would stay like this all the time, but let's be honest here, math isn't about keeping it easy. We gotta make things a little bit more difficult on ourselves. So let's try another problem real quick, okay? So, say for example, we have 5 over 12, okay, minus 5 over 18, okay? I wanna do this problem. I wanna subtract, but you'll notice here the denominators are not the same. The numerators are the same, but the denominators are not the same. Therefore, we can't just go ahead and say 5 stays at the top or 5 is on the top, yay! And then 12 minus 18, oh, that's negative 6, oh my gosh! That's not what we're gonna do, okay? That is not the right thing, okay? We can't do that, all right? So we have to get common denominators here. That's why we learned that in the last video, okay? Because that's the one skill we need in order to do this, okay? So let's go ahead and do that. So what is the least common denominator between 12 and 18, or what's the common multiple between 12 and 18, okay? Let's do that quick little trick. So 12, let's do the prime factorization of 12, which is 2 times 2, which is 4, times 3, which is 12. Okay, let's do 18. 18, the prime factorization of that. Well, let's see here. I know 6 times 3, 6 can be broken down. 2 times 3, which is 6, times 3, which is 18. Hey, pretty fancy. All right, now let's go ahead and write these out. So 2, 2, and 3. 2 matches up, and there's a 3 match, so I can put those below. There's an extra 3 left over, just like there's an extra 2 left over on the top one, so we can just leave those by themselves. Just drop down each of these columns. So there's a 2, there's 2s, there's 3s, and there's 3s. Let's multiply this together. 2 times 2 is 4, times 3 is 12, times 3 is 36, okay? So 36 is our common multiple for this, okay? So let's go ahead and start this problem over again, but this time we know the fact that the common denominator is going to be 36, okay? So starting with this, so I got 5/12 minus 5/18, and we know that 36 is the common denominator. So how do I go from 12 to 36? Because again, we have to worry about this denominator. So 5/12, well, 12 times 3 is going to give me 36. So let's just multiply the top and bottom by 3, okay? So 5 times 3 is 15, and then 12 times 3, well, that's just going to give me my 36. Awesome. Now, the next one, 5/18. You can just worry about the fraction first. Don't worry about the subtraction part, okay? We can rewrite that when we're done, okay? So 5/18, how do I get the 36 from 18? Well, we multiply it by 2, so that means the top and bottom have to both be multiplied by 2. So 5 times 2 is going to be 10, and then 18 times 2, well, that's going to give me my 36, okay? So here are my two fractions that I'm going to use now for the final problem, okay? So let's rewrite it. So 15/36, which is, originally it was 5/12, but turned into that so we could have common denominators. Now we're going to just have that minus sign because that's the way it was in the original problem. 10/36, okay? That is now common denominator, all out, oh, fun stuff. And now we're just there ready to just do the subtraction part, okay? So equals 15 minus 10, that gives me 5, and then 36, okay? And that's it, okay? We asked ourselves, well, can this be reduced down? And the answer is no, because the greatest common factor for both of these is 1. So we are done. All right. So let's do one more, and then we'll call it quits for the day. Here we go. Clearing page. Let's just do a quicker one. Let's go ahead and say 3/5, and we're going to add 4/11 to that. Okay. Now, done this ahead of time, so this time I'm just going to cut to the chase. The greatest common multiple of 5 and 11 is 55. So how do I get from 5 to 55? How do I get from 11 to 55? Okay, so here we go. 3 times 5, we're going to multiply this by the fraction of, well, 11, because that's how I get to 55 from 5. So both of these have to be multiplied by 11. So 30 times 11 is 33. 5 times 11 is 55. There is our fraction for 3/5 and changing that in terms of 55 as the denominator. Let's do that for 4/11. How do I get from 11 to 55? Well, we have to multiply both the top and the bottom by 5. All right, so 4 times 5 is going to be 20. Ooh, what is that? Ooh, I haven't used this before. Side note, I love this eraser tool. So exciting. Fancy smancy stuff. All right, so 4 times 5 is 20. 11 times 5, well, that's 55, okay? So we have done our math. We have common denominators. Let's go ahead and add that together, okay? So 3/5 turned into 33/55, and we're going to add that with 4/11, which is now turned into 20/55. Let's go ahead and add that up. So 33 plus 20 is 53. And then 55 stays the same because, again, when we add fractions, the denominators stay the same. All right, 53 and 55, greatest common factor of those is 1, so therefore we are done. And in fact, we are just done with this video, okay? There's fractions for you. I hope that helped. If you have any further questions on fractions, you can pull me aside in class. What I would recommend now is by the time you're done with all these videos, you should be able to work on the fractions worksheet, okay, which is linked somewhere below, okay? So have a good day, and we'll see you with the next topic. Bye.